So if we know the surface area of a cube varies directly as the square of the length of an edge, so let's let S be surface area. And let's let L be length of an edge. And it's giving us that S equals something times the square of the length of an edge, so that's L squared. So S equals KL squared. The surface area is 24 feet when the length of its edge is 2 feet. So we put 24, and we can solve for our K. So the length of an edge is 2 feet. And so then we can divide that over. 24 divided by 4 is 6. Okay, and so then I want to find the surface area of a cube with an edge that is 7 feet. So the surface area is going to be 6 is my constant, and then the length of the side is 7 feet. So if I compute that, I get 294 square feet. Okay, then I have a system of equations. I want to determine if an ordered pair is a solution. So this is an x and this is a y. And so what I'm going to do is plug in that x and y into both equations and see if it gives me a true statement. So I have 3 times negative 2 minus 5 times 1/5. And let's see what that equals. That gives me negative 7. So that one is true. And let's see if this x and y pair fits the other one. So I'll have negative 2 minus 4 times 1/5. And I'll tell you that doesn't look promising there. So I have negative 2 minus 4/5 gives me negative 2.8. So that one does not work. So this is not a solution. So it's important to check both equations because it could be a solution to one but not a solution to the other one. So you have to check them both. Okay, so next we're going to check this equation to see if it is true here. So we're going to check this x and y pair. And we're going to plug it into, again, both equations. So let's plug it into the top one first. So you have 3 times 1 minus 5 times 2. What does that give us? 3 minus 5 times 2. So that's 3 minus 10 is negative 7, so that one works. Then I have 1 minus 4 times 2. So that gives me 1 minus 8, that's negative 7. And so that one checks out as well. And so this is a solution. So we checked that x and y pair with both equations to make sure it worked. Then this one says solve the system using the substitution method. And so what I'm going to do is I'm going to take equation 1 and I'm going to solve it for x. So I'm going to get x is equal to 5 minus 3y. And then I want to substitute that in place of the x there in equation 2. So there's the x, because that's something that x is equal to. So in place of x, I'm just going to write that statement there. So I'll have 3. So in equation 2, I have 3. And then in place of x, I'm going to write 5 minus 3y minus 2y equals 18. And I can solve this now for y. So I'm going to distribute that 3 into both of those. And I get 15 minus 9y minus 2y equals 18. So that's 15 minus 11y equals 18. I can subtract the 15 from both sides. I have negative 11y is equal to 18 minus 15. That's 3. So y is equal to 3/11ths. And that's negative 3/11ths. And then I can find out what x is. So if y is negative 3/11ths, then x is going to be 5 minus 3 times negative 3/11ths. So this is 64. I'm going to end up with 64 11ths when I do that. So it's going to be 5 plus 9 11ths. So 55 11ths plus 9 11ths is 64 11ths. So that's my x and my y. Okay. And the next one, I want to solve it using the addition elimination method. And so what I want to do is I'm going to look at the x column and the y column, and I can see that if I multiply this top by 7, each of these guys by 7, I can add straight down and the y's will be eliminated. So in other words, my system has now become 42x plus 7y equals 7 times 4, which is 28. And then I'll have 20x minus 7y equals 3. And I can just add straight down each column. So if I add both sides, I'll have 42x plus 20x gives me 62x. And then my y, 7y minus 7y, that adds to 0. And then 28 plus 3 is 31. So I can divide that over and I get x is 1/2. And so if x is 1/2, then I can just plug that into one of my equations. I'll just plug it into this top one. So I'll have 6 times 1/2 plus y equals 4. And so that gives me 3 plus y equals 4. So I can subtract that over, I get y equals 1. So x is 1/2 and y equals 1. So I'll write them near next to each other. Okay, for the next one, it says Brian and Jaden had barbecue potato chips and soda. Brian ate 3 ounces of chips and drank 2 cups of soda for a total of 700 milligrams of sodium. Jaden ate 1 ounce of chips and 3 cups of soda and had 350 milligrams of sodium. How much sodium is in 1 ounce of chips and how much sodium is in 1 cup of soda? So let's let x be the amount of sodium in 1 ounce of chips, and we'll let y be the amount of sodium in 1 cup of soda. Okay, and so what I'm going to do is I'm going to make 2 equations. One equation has to do with the amount of sodium Brian consumed. So Brian had 3 ounces of chips, so it's going to be 3 times x is going to be the amount of sodium that he ate that was in those chips. Plus, he drank 2 cups of soda, so 2 times y would be the amount of sodium that he ingested from soda, and it totals up to 700 milligrams of sodium. And then we'll make a similar statement for Jaden. So Jaden ate 1 ounce of chips, so we'll just write x, and then he drank 3 cups of soda. And he totaled with 350 milligrams of sodium. Okay, and so what I want to do is solve that system of equations. And so we could do it lots of different ways. I think maybe doing an elimination might be easiest. So if I could multiply everything by -3 on this bottom equation, then the 2 equations that I will have will be 3x plus 2y equals 700. And on the bottom, I'll have -3x minus 9y equals 350 times -3 is -1050. And then if I add those together, I get -350, and I'll get -7y, and then I get y is equal to 50. And the units of that are going to be milligrams. And then if that's what y is, then I can take this equation 2 that I started with, and I can say x is equal to x plus 3 times 50 So I get x is equal to 350 minus 3 times 50, which is 200. So 50 milligrams of sodium in 1 cup of soda, and 200 milligrams of sodium in 1 ounce of chips. So that's the answer. So in 1 ounce of chips, there is 200 milligrams. And in 1 cup of soda, there is 50 milligrams. Solve the nonlinear system of equations using the substitution method. Okay, so here I want to solve for either x or y. So I think I'm going to take this bottom one and I'm going to solve it for x, and I'm going to get x is equal to y plus 3. And then once I do that, I can substitute that into equation 1. And so I'm going to get y plus 3 minus 4 squared plus y squared equals 25. So that's going to give me y minus 1 squared plus y squared equals 25. And so that's going to give me, let's see, y squared minus 2y plus 1 plus y squared equals 25. And I can, from that, I can make a quadratic. So I'll have 2y squared minus 2y minus 24 equals 0. And then if I factor that, I'm going to get 2y and y. And let's see. Things that multiply to give me 24. Let's do a 3 and an 8. Okay, and I want the 8 to be negative and the 3 to be positive, because that's going to be positive 6y minus 8y. So I'm going to get y is equal to 8 halves, which is 4. And I'm going to get y is equal to negative 3. Okay, and let's find the x's that go with that. So if y is 4, then x is 4 plus 3. So I get 7, 4, and then I'm also going to get, if y is negative 3, then x is 0. So those are my two solutions. So the solution pairs have to go with each other. So when y is 4, x is 7, and when y is negative 3, x is 0. So I'm using this equation to figure out what the x is that corresponds with the given y. So for the next one, I want to solve this system of equations. I'm going to erase some of this. And go with blue. And again, I can see this is a nonlinear system of equations, and it looks like it's set up nicely to go ahead and add those together. So I'm just going to I'm going to eliminate the xy term because I want to just be able to solve for y. So if I multiply this through by, I want to get rid of the xy term. So I'm going to multiply this guy by negative 3, by 3, and I'm going to multiply this guy by 2. And so my resulting equation is going to be 6xy minus 3y squared equals negative 72. And then I'm going to get negative 6xy plus 4y squared equals 38 times 2, which is 76. Okay, and then I'm just going to go ahead and add those two. And so this xy term goes away, and I'm just left with I'm just left with 4 minus 3y squared. So that's just 1y squared. Y squared equals 4. So I get y is equal to plus or minus 2. And so then if I take those and plug them back in over here, when y equals 2, I'm going to get 2x times 2 minus 2 squared equals negative 24. Okay, and I can solve that for x. So I get 4x, negative 24 plus 4 is going to be minus 20, so x equals negative 5. So that's a pair that goes together, is negative 5, 2. And then if when y is equal to negative 2, what do we have? Well, that gives me 2 times x times negative 2 minus negative 2 squared equals negative 24. All right, so that's going to be a negative minus 4 there, so I can add that over, and so I'll get, again, a negative 20 when I add that, and 2 times negative 2 is negative 4x, so I'm going to get x equals positive 5. So I'm going to get positive 5 comma negative 2. So those are my two solutions. The next one says the difference of two positive numbers is 3, and the difference of their squares is 33. Find the numbers. So I'm going to say that y minus x is 3, and y squared minus x squared is 33. And then I want to find those numbers. And so I'm going to get, if I add that x over, I'm going to get y is equal to 3 plus x. And then I can plug that in. So I'm going to get 3 plus x squared minus x squared equals 33. And then I get 9 plus 6x plus x squared minus x squared equals 33. So the x squareds go away. I can subtract the 9. 33 minus 9 is 24. So I get 6x equals 24. So that gives me x is 4. And so what does y need to be? So y needs to be, we have y minus 4 equals 3. So I can add that over, and y is 7. So we have x equals 4, y equals 7 as my solution. Let's just check to make sure that's true. 7 minus 4 is 3, and 7 squared minus 4 squared is 33. So yep, that works. All right, I think that's it.